All right, so we can use mass, we can use molarity, we can use mass percent, we can use all kinds of different units. Again, the main point is that we're going to go from some unit of A, we're going to somehow get to moles of A, and then after we get to moles of A, we're going to use our stoichiometric coefficients to get to moles of B, and then we're going to go from moles of B to whatever the question is asking about for B. But the main point is that we somehow need to get moles of A to get to moles of B. So you always want to go for moles of A. So let's take a look at the reduction of iron oxide. So when they like dig out, if you want to, collect iron from the earth, it doesn't come out as like shiny metal iron bars. It comes in salts in iron oxide form, and then you reduce it. You can use like carbon monoxide or just a carbon source. There's multiple ways to reduce it. And then you get a bunch of iron out, and then of course you're going to produce some carbon dioxide gas. So anyways, so let's say that I'm mining out this iron oxide out. That way I can make some iron. So let's say I have a rock that is 32% iron oxide by mass. How many grams of iron can I get if I have 125 grams of rock? Right, so my rock contains some iron oxide, but it's not pure iron oxide. So how much iron can I get out of this rock if I have 125 grams of it? So again, we want to think about what we want. So it says, how many grams of iron do I want, right? That's what I want. I need to keep converting until I get grams of pure iron. And I think about what my other units are, and are they conversion units? If so, maybe it'd be useful to write them out as conversion units. So this says 32% iron oxide by mass. That's a conversion unit. It means 32 grams of iron oxide per 100 grams of solution. In this case, what it's talking about is 100 grams of the rock. So maybe we can write that out. That might be useful. If I think about what I want to start with, I want to start with a thing that's not a conversion unit. This is a conversion unit. I can use my stoichiometric ratios as conversion units, and then I have 125 grams of rock. Well, that's not a conversion unit. So we can write that out. And then I can start converting. Well, if I think about my rock, right, I have it right up here. It's 32% iron oxide, but it's totally rock. So I can use that conversion unit down here. 100 grams of rock, 32 grams of iron oxide. And then I cancel out rock with rock. Now I'm at grams of iron oxide. Well, now I'm at grams. How do I get to moles? Because remember, we always want to get to moles of A. Well, we can simply use the molar mass of our iron oxide. According to Google, I got 159.69 grams per mole for the iron oxide. Note that I put the grams on the bottom. That way they cancel out. Now, what units am I left with? Well, currently I'm at moles of iron oxide. Well, once I get to moles of A, I can then go to moles of B using my stoichiometric coefficients. So for every 1 iron oxide, I can get 2 irons. So I'll put 1 iron oxide up here. I'll get 2 irons out, and then I'll cancel out my iron oxides, and I'll be left with iron. And then at the end, I want grams of iron. Right now, what am I at? I'm at moles of iron. So how do I get from grams to moles? Well, that's the molar mass. So the molar mass of iron is 55.845 grams per mole. So moles and moles cancel out, and then we're left with grams of iron. I then go ahead and do all the math. Note that I'm not plugging anything into my calculator until the very end. I'm showing all my work nice and neatly, and I end up with 28.0 grams of iron, which is exactly what I wanted. I wanted grams of iron, and that's how it goes. Again, practice, practice, practice.